So let's sorry, let's do exactly the same for the second macro here that I promised you would implement. So I'm just gonna, of course, collapse this terminal so we have some room to work. And now I can, of course, collapse this as well. And for this, is really gonna be pretty straightforward. So sorry, it's gonna be, we should be able to provide, of course, give it a name, then provide the struct, and then implement the getters and setters for that struct. It's as simple as that. So I'm just gonna copy all of these parts, come down here, come on, close this. Oh, come on, seriously. So I'm gonna copy this one more time and dump this down here. And for this one, I'm gonna call this, I don't know, something like derive. I'm gonna probably implement, I don't know, maybe, okay, can I call it also derive getter setter, something like this. And I'm not gonna accept additional things. I'm not gonna accept additional things. Just this should be fine. There's not gonna be any attributes for us here, so it's gonna be straightforward. I will also try to still add some comments so you can easily read this code much later. So I can say pass the input, sorry, input token. And then down here, I can say let input. So input is going to be, again, say pass macro input. We're going to use this macro. And then we again provide the token. I say I'm still going to say something like derive input. So now I can also double click this to have this in here. And I don't know why that keeps popping up. So we have our inputs, and what I would like to do, of course, is exactly like we did before. So I'm going to extract struct name. So I'm also going to give it that same thing. So I'm going to call it let struct name is equal to input dot input.ident. So now we have the struct, and I'm going to again double click this to have this if it's going to let me. So now we have the struct name. So now I would like to generate the code. So inside down here, I'm going to say something like maybe also for your easy understanding, I'm going to say generate code. And I might say something like only input is a struct. So just like we did initially, we also have the option of actually evaluating this. So if it is a struct, we proceed. If not, well, we don't do anything. So in here, I can create, of course, what I want to return. So I can call this again expanded. So this will be the token stream, like the code, and that will be expanded in the end. So I would like to use the iflets syntax. So again, let's go through sin and then go through data and then struct. So if struct, so I'm gonna, this is the data struct. So I'll also maybe explicitly write it out. So if this is the case, I would like to do something, and maybe if this, again, in the other one, we are really basically panicking. But here also what we can do would be, I don't know. So maybe I say if this is the case, else, I'm gonna return an empty. So I'm just gonna say quotes, something like this. So that way, of course, if nothing is, if this is not a struct, I can maybe come here and say otherwise return empty implementation. So here it's really not going to return anything anyways. Okay, but an interesting thing, of course, would happen in here. So let's proceed. So I'm going to come back in here, of course, and the next thing I would like to do would be to pass loop through, of course, to get the fields, just like we did before, to get the named fields of the struct, and then implement the getter and setter for them. Basically, that's what I will be doing. Okay, so pretty straightforward, but to do that, I would like to create a couple of placeholders. So I'm going to have one called getters and setters. It's going to be a vector. So I'm probably just going to use the syntax. So it's going to be a vector like this. And I need to create another one. So these are all going to be a vector of token streams. So, but let's proceed. So constructor, I'm going to call this constructor fields. Again, pretty similar to this. And the next thing, of course, maybe I can call this constructor constructor params. Again, it's going to be a vector just like we defined in here. And so here I want to call this constructor, not construct, so it doesn't confuse anyone. So, okay, let's also add comments. So now I can say we would loop through each field in the struct. And now in here I can say if let sin, I want to look at the field, and again I'm interested in the name, so I can say named, and I pass fields. So these fields will basically get this from data. Let me see, what did I call it? So data struct common dot sorry, fields common data struct. So what is the problem? Oh, my bad. Of course, this is not even instantiated. My bad. So this should be, of course, input.data. My bad. So now let's proceed. So what is this error? No associated. Of course, I need to probably handle all these imports. So maybe I should not do them like this. So this is coming from data anyways. What happened? Did I close that? So saying that's data. Let me see. Okay, so I'm going to saying that fields that's named, of course. What is the problem? Oh, I think this should be fields. Oh, sorry, my bad. Okay. Maybe I'm being too fast. I don't know. So, but anyways, so now I can loop through my named fields. So I can say for field in fields that's named. So for each of the fields, what we would like to do, of course, is to get the field name and the field type. So I can say let's field name. So this is going to be of the field that's ident. And I say as ref when I borrow this. And now I say, of course, unwrap. So I have the field name and field type. Field ty is also going to be quite similar. So I'm going to say something like field.ty. And I have the field type. And now, again, I'm going to add comments all through. So now I can say generate a getter method, something like this, for each of the fields. And what we can now do here is I can say let's getter function. So this is the function I want to create, and again I would of course use the token stream to return the content of this function. So this is going to be pretty straightforward. We are going to implement a function for our structs, and then we'll provide the name of this function. So that's really what we're going to do. So in here, I'm going to say, if I can type, so I say import, we need to implement the struct name. That was what we called it, right? So just to be sure. So import this, And then within the implementation block, now I need to, of course, add the function. So it's going to be a public function. So I provide the field name, and I would like this to, of course, look something similar to the name that the user is providing. So that's why I'm also using it like this. So, but anyways, it's going to be taking reference to self, and it's going to return, of course, a reference, in this case, to the type. So I can say field ty. So this is us, of course, specifying the type of the return type, basically, of this implementation. And down here, all I simply need to do now is return self dot field name, and I close this up, of course. And that's basically all we need to also really implement our getter method. Basically, it's really that straightforward. And now what I can actually do is I can come down here, and now I say getter setters, and I can say dot push, and now I pass my getter function. Okay, that's really it. So now we are done with implementing our getter methods. And now the next thing, of course, we implement in that vein also would be to add the comments again, so you can easily read this later. So I say generate a setter for each of our fields, like this. Again, pretty straightforward. So I call it again setter function. And setter function is also going to be, again, we use quotes. Again, this is where we return the token stream that needs to be returned back more or less by this macro. So that's why we always have to use this. Anyways, I'm going to do exactly what we did before. So implement, again, we pass the struct name. And now again we create our get setter method. So in here I create a public function, and I call this let me see, I only have I need to generate some names because I want the name to be, so if you provide, for example, something like first name, I want to be able to say set first name, something like that. So I'm going to generate a list of names. So again, I'm going to add a comment here so you understand what we are doing. So I can say generate the setter method names dynamically like this, and I can say setter name. So setter name would be something like ident. I create a new ident. I say ident dot new. And basically I need to just provide a string in here. So I can score the format macro and simply say something like set. So now I pass the name of the field. So like I told you, first name, I should have set first name, something like that. And in here, now I need to provide the field name. And of course, what I can now do is to span through my field. So I can come here and say field name dot span. I call the span method. And now that's how I create. Why does this keep popping up? That's how I create my setter name. And now what I can simply do is just copy this setter name, come down here, and this will be the name of the function. And now I implement the body. So the body is again gonna be pretty straightforward. So, but the interesting thing again for this would be in here, it should be able to take a mutable reference to self, and of course a value that is going to be, in this case, field type should have type field type, so field ty, because we want to make sure that you don't provide the wrong type. So of course this is coming from the scene package. And so now we have the method, of course, the body. This is really setter. So what I would like to do, of course, is just to update that field. So I can say field name would now be equal to the value that you provide. And that's how we actually implement the setter function. And again, I can push this to our getter setters, I can say getter setters dot push, and I pass my setter function. So now this should have been annotated, of course, with token stream because the type has been inferred. Okay, so at this point, we are done implementing the getter and setter. So what I would like to do now is, of course, to collect the fields and parameters for the new function. So I can also maybe add a comment in here and say something like collect the fields and parameters for the new function, something like this. And now I can say constructor fields. I call this guy dot push. And now I push again, I want an implementation. So again, I use my quote. And inside here, I just want to pass the field name. And again, it has been inferred. This is of type token stream. And then constructor params do exactly the same. So constructor params dot push. Again, I pass my quotes. And in here, I would like to pass a key value. So I'm going to do something like this. Say field name. I provide, of course, field type. Okay, so now what I would like to do is after this point to now basically implement, no, not here actually. So if this is the case, I'm gonna remove this for now. And we will come back to this much later. So now down here, I can again add a comment. I can say generate the, I want to generate a new constructor. So I can say import, now let me create the function first. I can say new fn. So new function, again, I'm going to use quotes for anything I want to return that's going to be expanded later. I'll close that up. Again, it's going to be an implementation. So it's going to again be for our struct. So I say struct name. And in here, I would like to, of course, implement a new method. So I call this new. Again, I'm going to dump all my parameters. So I'm going to use that syntax that you've seen before. So this one. So we're going to start and close it with ampersand and asterisk. And inside of this, I would now, of course, provide my constructor params, and I'm going to add a comma in the end. And what I would like to do, of course, is that this should return self as is the convention more or less. So we now have to provide the self, and then in here, I'm just going to dump the fields. Again, we are using that same syntax. And then in here, again, just like we did before, I'm going to pass my constructor fields. Sorry, my bad. So in here, I'm going to pass my constructor fields. And that's basically it. And so now we have our new function, and now I would now, of course, bring it all together. So I can simply return quotes. And in here, I'm going to add my getters and setters. Again, I'm going to use this syntax one more time to dump everything in here. So again, I'm going to dump my getters, setters, should be this guy. And after that, I'm going to also dump my new function like this. What is the problem? Why do we have a problem? Or if maybe, of course, it's missing an else part. Wait, let me see. So for it ends here, this guy ends here. So now down here, we can simply add our That was also why I wanted to do this in the end, because I had a lot of curly braces and I was no longer sure where they should be. So, but anyways, at this point, you can panic or whatever, but in my own case, I'm simply returning nothing basically. And then of course we still don't return what we need to return. So now I can say token stream and I say dots from and I add my expanded like this, and that's the end of our implementation. We seem to have some error, and what is it? Name blah blah blah. Okay, we have, do we? Of course, the function is duplicate. So now I can actually call this setter getter builder, something like this. Okay, and basically that's the end of our implementation. And now what we can simply do again is to try to see, to use it of course, and see what we get in the end. So I'm just going to come back to main. I'm going to again, for to make it interesting, I'll create a new struct and I call this person. I don't know, person. Person is also going to have these two things. I don't know, but I'm not going to make this optional for now. String, comma. So I'm going to make it strings, so it's not going to be optional. And maybe also person is also going to have age, which is going to be of type I32. So now we can again add our implementation. So I can dump this here, but now I don't really want to put this. Of course, in this case, it's not going to be satisfied. If we hover over it, we should be able to, of course, see. So one, they need to be optional, and when they're also optional, we should be able to, of course, provide this attribute. But anyways, now what I would like to do is to return the other implementation we had. So it was setter something, derive setter getter, something like this. And I'm just going to copy this again, bring it down here. And we seem to have an error, so let's see why. So we are good to go. So but if you look here now, you see we have 8 implementations, and then you ask yourself, how many implementations do we have currently? I'm going to leave debug, of course, because we want to be able to log this. So but if I remove it, of course, reduce this to 7. And the point why is because we have here 3 attributes. So those 3 attributes gives us 6 implementations, because we have getters and setters for both. And we also have the new method we added in the end, making it 7, then plus debug 8. So what it means is that if I add a new thing here called address, that is a string, is going to add 2 more, and now it goes from 8 to 10. So that's the interesting thing, because now we can actually come down here and I can say let person. So person is going to be of type person, so one we just created. So now I can of course provide everything. First name, I can say Tony dot to string. I'm just going to copy this because I'm really tired of typing. And last name, I'm going to say 18. And I say, I don't know, address, I can say Germany, and then age, I can say 34. And now we have a person. So now if I look at person, I can now say person dots, and now you see we have a method to get address, first name, as you can see, is a function. So address, first name, age, last name, as you can see, and now we also have our setters. So one thing we could have also done is to, if you look down here, where we did the formatting for the name for our setter names. What we can also do, just like we did down here, is to also do something like this. I'm just going to copy this. And instead of using this field name in here, I'm also going to do something similar. So I'm going to dump this here so I can call this getter name. Okay, and then I replace this with this getter name. So now it's going to take a while to of course, recompile. I think I can maybe even restart my server and then we can test this. So I can come back in here. I think I made a mistake of leaving this as set, so I can change this to get, and everything should be fine. We seem to have some, I'm gonna remove this unused import, and this should be fine. So I can come back in here and now we can continue. So I can now say person dot. Now it's no longer just age, it's now get age, get first name, get last name, gets where is the other one, get address. So, and we can actually even call out this method. So I'm gonna say, maybe I move this around a little bit to actually be consistent with what we are doing. So I can bring this up here, take it out again, and yes, bring it up here. And then maybe add some comments, and this would be our SQL builder example. I want this to be as easy as possible for you to understand. So this will be our setter getter example. And now we can now print, of course. So now I can say, I don't know, I'm probably not going to be able to do it for all of them, but again, feel free to do exactly that. So here I can now say person dot get first name, like this. And now let me open this up and then say cargo run. And it should be able to, of course, return our first name first. So quite handy, as you can see. So if I should, for example, change this to, I don't know, whatever it is I want to do, maybe I change this instead of I32, maybe I change this now to I64. Sorry, not one, I64. For example, if we look at now, if I come down here, for example, and say something like person.get age, you see it updates. The return type is now, of course, I64, because again, we took care of that. We got the type of the field from the struct, and that's also what's the implementation we have here basically. So we'll provide the name and we'll provide the return type. That's basically what we did here. So again, feel free to go back later, come back and read this, so maybe you understand really what's going on. So guys, moving on, we've been able to cover these two. Again, I'm going to be maybe quite fast now, and then see if we can cover these two, the builder pattern and of course the factory pattern as well. So pattern. Okay, let's proceed. I'm going to come back in here now and I'm going to copy this and collapse this once again. So, and then I drop this here and I'll call this something like builder pattern. So this is where we would implement the builder pattern. So I can call this derive builder pattern like this. And again, this is going to be pretty straightforward, like that, like what we did until now. So again, I'm going to copy this, copy the comment as well, comment down here. And now we have the derive input. So let's now proceed. Again, I'm going to also maybe take the struct name. So I copy this as well because I'm really getting tired. So we have the struct name as well. And now one thing I would also like to get will be the builder name. So I can say let's builder name. So builder name is going to be, again, I'm going to create an ident. So I can say, do I need to import this? Syn ident new, and I call the new method and I provide a string. So I'm going to say format and provide, so this is going to be builder, and I want to provide the struct name. And so of course this should be a macro. And so, and now, sorry, I need to provide a span. So I can simply say struct name dot span. Okay, and now I have a builder name. And now again, I'm going to do like we've been doing. So I can say let's expand it. Again, this I'm going to use the if let syntax. I say if let sin dot data dot struct. So if it is a struct, then we are in business. So I can call this data. This will be my data struct. And this of course would come from input dot data. So if this is the case, of course we are in business. Otherwise, we simply again return quotes just like we did before, nothing fancy. Again, we close this up so we have something in the end. But now, of course, the return types are different. So again, we are good. So in here, I would like to create some variables. I can create one called my builder fields. So builder fields. This would be again like a vector, like this guy. So I need another one, and I'm going to call this builder methods. It's again going to be a vector. Close it up. So I create another one. I want one called my build fields. So I'm just called this build fields. Again, it's going to be a vector as well, or going to be of type vector of token stream. And again, like I did before, I need one again that's going to hold my constructor parameters. So I'm going to call this constructor params. Again, it's going to be a vector as well. Okay, so these are some of the things that I would like to create. And now again, I loop through the fields like usual. So loop through the fields of the struct. Okay, now I can say if let sin fields this guy named, and of course can call these fields, and these fields again is going to come from data.fields. So if this is the case, now I have to loop through field in fields.named. So for each of the fields in our struct, I would like to loop through all of them. Again, this is really just like we did before. So again, I'm doing this a couple of times just so because I want you to get used to, really working with this. So we loop through the field names. So and now we extract the field name. So ident field.ident, and I want to use this as a reference. So I can say as ref. And then I unwrap. Again, you don't have to do unwrap. You also can handle the error just like we did in the first one. So anyway, again, I'm interested in the field type. I'll call this field ty. And again, this is going to be from field.ty like this. So armed with these two interesting things, we are good to go. So now I can, let's say, I don't know, build structs. I can maybe, okay, let me keep it simple. I'm just going to go ahead and say builder fields dot push. And what do I want to push? I want to put the token stream. So I say quotes. And inside of quotes, what do I want to provide? I want to provide, of course, I want to make every field, because again, this is a BuiderPattern. I want to make every field optional. So, okay, maybe I add a comment here. So here I say builder struct will have option types for each field. So all the fields needs to be optional, so we can work with that. So I need the field name. Again, I need to of course provide the type. So std from the standard library. So I go to options and I go to option. I say some. Sorry. Think just want to provide a type. So in here I provide my field ty. to provide the type. Nope. And I've provided the field. And the next thing I want to provide, of course, would be the method. So I say builder methods dot push. Oh, come on. Dot push. And in here again, I'm going to push a quote. What is it? What is it? Builder method is a vector. So is my LSP messing up? I don't know. Or maybe my editor is becoming overburdened. I'm not sure why, but it's fine. So again, I create my function. I would like to use, of course, the field name. This will be the name that it has within our struct. So it should be able to take a immutable reference to self. And again, it's just going to take a field name, which is going to be of type field type. Again, field type. So that's how you reference all of these variables within. This is, again, pay attention. This is within the quote block. That's really the difference you need to note here. And it should always, of course, return immutable reference to self. So if you are familiar with the builder pattern, where you are doing things like, I don't know, anyways, I'm going to show you. But again, if you don't know anything about a builder pattern, I'm going to again leave links so you can see, because we've already implemented this in the past, but now we are doing it with a macro. So we can now say self.field name. So this field name would now be equal to, say, std, so sorry, standard library option, and we go to option, and now I can do sum, and I provide my field name. Okay, like this. Okay, and that's for the method. And the next one, of course, would be the build field. So I can say build field build fields dot push, again, quotes, provide our quotes. And then in here, I would also like to do some similar. So I can say field name. So this would be within the build function. So we would unwrap the fields more or less to get their values. So I can say field name is equal to self dot, again, I access field name, and I can say that take. And now as add, of course, try to handle the error, as I say expect. And then here I would like to, of course, maybe give a user a reasonable name. I can use the concat macro. So I can say concat. And in here now I provide two things. So I can say, I can first call stringify to basically stringify the token, in this case field name, as a field name. And the next thing I want to provide is a string that simply says is not set. So in this case, it's going to say first name, whatever is not set, last name, whatever is not set, something like that. And the next thing, of course, that I would like to implement. Okay, so I just noticed for the method, we are not really returning anything, so I can simply say self. So we return self. And the next thing, of course, I would like to implement here would be the constructor. So I can, sorry, to append our constructor params. So I can say constructor params, just like we did before, dot push. And then in here again, I pass my quotes. And in here, again, I'm going to do something similar. So for initialization, I'm going to make all the fields, so I have the option of making all the fields none. So I can say field name. Again, it's going to be something like from standard library option, we go to option and none, like this. Okay, let's proceed. And now we actually done handling our fields. And now the interesting thing, of course, again, like we did before, would now be to implement our struct. So I can say let's builder builder struct would be, now I use again my quotes. This would be more or less what I would, of course, like to return in the end. So in here, I can now say pub struct and provide the builder name. Let me see. And now, of course, for the body, I'm gonna, maybe of course I close this up. So for the body, again, I'm gonna use exactly what I showed you before for when we have an iterable we like to iterate through and not do some funny looking for loop. This is one shortcut of doing it. So I can say builder fields, and that would be for the builder name. So now the next thing, of course, we'll now do would be to do the actual implementation. So we need to provide a function that you can actually now use to more or less have access to the builder pattern for your struct. So I can see import again, builder name. In here, I would like to again, I'm going to maybe add a comment here, and I can say dump all builder methods that we already have defined. So again, our fancy syntax in here. Again, I'm going to reference now our builder method. So builder methods like this. And let me see, import. Okay. Oh, sorry. My bad. Um, what is the error? Cannot find value builder name. Are you serious? Oh, builder. I missed an L. Builder name. Oh, I don't have time to do this. Okay, now it's found it. Okay, so now apart from this, sorry, should be inside our implementation actually. So within our implementation, I'll now implement, I can add the comments. So now import the build method, something like this. So now I need to have a public function called build, and build is gonna, of course, take immutable reference to self, and it should be now be able to return a result. So std for standard library, and then results, and of course results. So again, results should be able to return two things. One of them would be, of course, of a type that's of our struct name. And when that's not the case, we'd like to return, of course, a static common, a static string, so str like this. And now for the body is also going to be pretty straightforward. So we simply say okay. And in here, I'll just provide the struct name. So struct name. And now, of course, the body will provide our fields. So again, the syntax I told you about. So now I come in here and then provide our build fields. Okay, so now we have our implementation for the builder pattern. And now, of course, the last one will be to implement the struct itself to actually have our builder. So here I can say import again struct name, and inside here I'm going to add just one method to create the builder instance. So I can say create a public function. I can call this builder, for example, and it's going to return builder name. So builder name, and in here something quite straightforward. So builder name, and here again our interesting syntax. I would like to of course pass our common constructor params, builder name, our constructor params, and now we have our quotes, and we named it. What did we name it? Builder struct. So here I'm just gonna return builder structs, and we should be fine. I'm just gonna collapse this so we see we seem to have an error. So if this is the case, okay, because I need to close this up. So if this is the case, I think it looks fine. Let me see. Now I can return this, of course. So we can now say like user token stream dot from. Again, I'll pass expanded like this. And now we should be done with our implementation basically. So now it's really for us to go ahead and test this out and see if it's behaving the way we expect it to. So back in the main file, main project more or less, I can bring in the BuiderPattern in here. And I can also, again, to make it interesting, I'm going to probably maybe give this some comments. I say this is for the SQL query macro. Again, because I'm going to create individual structs for these individual tests. So I say for the setter getter macro, and then down here I would like to create a new struct. This is going to be for BuiderPattern macro. Again, struct. I'll call this user. It's gonna again be nothing fancy to be honest. I'm gonna copy this again and just dump it in here. So now we have this again. So now I can copy this, bring it in here, and now instead of this, I'm going to add our builder pattern. So let me come back. I think this should have been builder pattern like this. And so we'll come back here. This should be pattern, and pattern as well. Okay, so now the interesting thing is that we can come in here. So again, I'm going to add just to differentiate all of this. And I can say builder pattern macro or example. And I can say let user. So user is going to be of type user. And I'm going to copy all of this because I'm lazy to type new ones. And now we have our user. Again, I close this up, go away. So this would be one interesting way to initialize our user struct. But of course, maybe I call this user 0, 0, 0. So now let's get into the interesting part. I can say user 1, 1 would now be, I can say user. Now we have this builder method, which we implemented. And now we now have the option of doing something like this. So we can individually now say, dot address, as you can see, sorry, dot, what is the first name? First name. So say dot first name. And for first name, we can now, of course, provide the values. I'm probably just going to call it first name, exactly what it looks like. And I say dot into. And now we can also do for last name, we should have a method as well. And I'm going to call it last name again because I'm lazy to change it. So now dots into. And just like that, that's how you actually work with the builder pattern. So now we can say the next thing, of course, would be, let me see, what do we have? Users. So we have address and age. So address again, dot into. And now I can have lastly say dot age. I can say 34, and now I call the last method dot build, and of course this returns a result, and now we can call unwrap. And now we have our user. So they are basically both more or less the same. If we change all of this, first name to this, last name to this, and then address to this, then these two are actually exactly the same. We can actually say assets equal, and we can say user maybe that's, I don't know, first name and user 11 dot first name, something like this. And we can also actually print all of this. So I think we also added the debug thread, so we should be able to do something like this. I say user 00, and maybe we also just put it on separate lines. So this one would be user 11, and of course we provide those values. So user 00. Okay, so let's see. So I remove all of this, cargo run, and now let's see what we get. So of course, we get to this point, you also see the output is the same, and our assert also gets through. So this is what the builder pattern helps us to do. So we of course don't need to go in and implement all of this. So you can actually really steal this code and use it in your own project. That's totally fine. It's not a problem at all. And guys, the last but not the least, would now try to implement the factory pattern, and then we will of course round up because this is getting longer than anticipated. So now we would just implement the factory pattern. So I'm going to come back in here again, copy this first part, or maybe all of this actually, because probably wouldn't need that anyways. Okay, so let's me come back in here and let's close this up again and then just dump it here. And now I change this, I can just call this factory, maybe factory pattern like this. And then I remove all of this because again, we really don't need these parts. And again, we can proceed just like we've done until now. So again, I get the input, I have the struct name, maybe I actually call it struct name. I have the struct name, and the next thing of course now would be just like we did before to pass the fields, because again this would depend on the fields of the structs that we have. So now I can again say maybe I would like to create a name for the factory, so I can say factory name. Factory name would be again like we did before, ident sin ident, that's new. I call the new method, and I provide of course I'm going to do a format. And for this, I'm just going to say something like new, because I want to use the name of the function, the struct rather, to, of course, generate the factory name. So I can say new, and then in here I pass, of course, my struct name, and I say something like to string, and then maybe I also turn it to lowercase. So lowercase, I don't know, think this should be fine. And for the span, again, I'm simply going to do struct name dot span. Okay, and now we have a factory name. So now again, like I did before, I'm going to say let expanded. Expanded is going to be, we get this using an if let syntax. So sin data, again, I'm doing this multiple times, so this should be clear for you in case you would want to do implement something of yours. So we would get this, of course, from our input. So inputs dot data, and this would be what we return in the end. So in here again, I'm gonna say mute constructor params. It's gonna be a vector, and I also need constructor fields. So let's mute constructor fields. Again, it's a vector. These are the two things I actually need. Now again, my loop. So now I can say if let sin, I need to go through the fields. Go to the fields again. You can actually look through here to see what's really possible. So, but for us now, I'm really just using the named fields. So fields, named fields, we again come from data.fields. So we get our named fields if they do exist, and then we loop through them. So we can say again, if field in fields.named, this is the actual loop. So in here again, I'm going to get the field name. Field name is going to be field.ident. Dot again, I'm borrowing it, so I'm going to say as ref, and then unwrap. So this will be my field name, and then again I need the field type, so I call it again this field ty. So this would be again a reference to field.ty. So now I have the field name and the field type. So what I will now do, of course, would be to check for the attributes. So there has to be some attributes put, or maybe also add a comment here, and I say something like check for the command the factory. So I have to write it in a way it's descriptive. Factory attribute on the struct basically. So I can say let's mute is factory. I would like to have like a default value basically. So it's not just going to be a factory pattern, but I also want to have the option of marking certain fields in the struct with some additional attribute macros. And that's what I'm trying to process here. I will also show you how we can use this in a bit. So as I create a mutable boolean and I instantiate this to false. And now what I need to do is to check the attributes. So I can say for attributes in field dot attributes. These are the attributes of the struct, and I can say if we are able to find a field that is marked with factor, that's really what we are doing here. So I need to create an argument. I'm going to call this attribute meta name, and it's going to of course come from attribute.path. You can remember what we said about path. I'm going to get ident. So if we get this, now we just need to check the meta name. So if attribute meta name, I'm going to call this factory. If this does exist, then I'm going to change this to true. So its factory defaults would now become true. As simple as this. So now that we are done with this, next thing of course I would like to do is to actually pay attention to those default values. So I can now say if is default, if is default factory, if it is actually true, then what I would like to do, of course, will now be to push this default value to my constructor field. So I say constructor field dot push. Again, now I'm going to push a token stream, and I'm going to be able to do that with my quote macro. So now I can say field name. Field name would of course be default. That's default. Okay. If this is the case, this is what I would like to do. Else, if it is not a default field, then of course I need to pay attention to the type. So now I can say constructor fields dot push. Again, I use my quotes to actually provide the token stream that needs to be appended to this vector. And then in here, I again provide field name. And field name, the type of course will now be field type, like this. And the next thing, of course, will be I need to add the constructor field. So I can say constructor fields dot push. I use my quotes. And then in here, I'm just going to pass the field name like this. So this is how we handle for cases where we have factory name appended to some of our attributes. We take care of them like this. So now maybe I also collapse this. So now here, I can now actually generate my factory method. So I can say let factory method, and again I use my quotes for code that needs to be generated. So I say quotes. Again, I close this up because in the end it's going to be a variable. So I come back in here, and now I import struct name. So for the struct name, I need to add I need to add a function, a public function that's going to be, the name is going to be, of course, my factory name. Factory name. And again, I'm going to provide my constructor params like this. So again, I use this interesting syntax you might have seen a number of times now. So in here, I now pass my constructor params. And in the end, this should be able to return itself. So it should be able to return an instance of that struct. And we populate the contents like this. Again, exactly what we did before. So use the syntax one more time. And then inside now, I provide my constructor fields like this. So this is how we provide our factory method. And here I can now actually return the factory method. Okay. So if this is the case, we return this, else we return an empty implementation. So I'm going to close this up, and now at the bottom here, just like before, we return token stream dot from expanded like this. And that's mostly all we have to do. Again, I have to change the name. So here would be factory builder, something like this. So now I come back to the main, and again I need to bring in this thread. So I can maybe put this in 2 lines to make it a little bit interesting to look at. Okay, so I now have my factory pattern like this, and now we have it in scope. And now again, I'm going to create a new struct to showcase our factory pattern like this. Again, it's also going to be some quite interesting, nothing so fancy here, actually, in my opinion. So it's going to also be like maybe I can even just copy one of these and then we modify it. So I can just come down here and paste this. So, but now I'm going to change this to factory pattern. And of course, I'm going to call this maybe teacher. So now we have a teacher and it has 2 implementations, as you can already see. So, but what I was talking about regarding the factory methods is that I would like to, maybe I can, because you're talking about, I'm probably just going to make this product. So that I'm going to have ID. ID is going to be, I don't know, maybe, so U32, doesn't really matter. And I'm going to have a name, so product name. And maybe this will now be my product price. And I think that's really it. That's probably all I need. So now I have a product. So, but what I was talking about is that if I wanted to provide some defaults, I should be able to come down in here and add some attributes. You might have already seen something like this with other with other threads that we've used in the past. So I think we might have forgotten to, of course, provide this factory as attributes. So I'm going to come in here and provide these attributes and call this, of course, factory. So let's come back in here, and now we should be fine. Of course, we cannot name it any other thing we want. It's going to complain. But it also tells us also there is something similar called factory, but yeah, so it should be called factory. So this is how we can provide some default value for our implementations, basically. So the interesting thing now is I can now come down in here. So, so down here, I'm going to say factory pattern example. And here I can say let's product. So I should be able to do something like this now. Products, and should be able to now say dots. And now I can say new product. And it's really dependent on what I call this struct. So to also show you, I can come in here and say productify, something like this. And of course, this is going to complain, that's also fine. So I say, maybe I remove everything. So also he gives me hints. So I say productify, and now it says new productify also. Quite interesting. And now it asks me just for two things, price and ID. And that's simply because here I am appending this as default. If I should take this out, for example, you would see here it's also going to complain. Now it's going to ask for three things. That's really the interesting thing. But if I don't want to do this and provide string that's new or whatever at the default value, all I simply need to do is to come here and of course comment this out, and it's only going to ask me for just these two things. Okay. And again, if I also, I don't know, want to silence the ID, sorry, I meant to copy that. If I also want to silence the ID, I can also do something like this. And now it's only just going to ask me for price, as you can see. So I can remove all of this now and say 25 or 23, doesn't matter. And we have a product. And that's really the interesting thing. So you have this flexibility to annotate your structs this way. And now I can actually do something like you can actually print this whole thing. You can say, wait, we had ID, we had price, name, and we had price. So we can now say ID and name and price. So we can provide all of this here. So products.id, products.name, products.price. Okay, and now we can also test this out. Cargo run. And it should be able to actually give us the default value. So the default value for our U32 is of course 0, and the default value for our string is of course an empty string. Again, that's really one way we can work with this. Again, I can maybe remove the default value we had on name, and now it's going to ask me to provide a name. Okay. And I can also gladly provide, that's not a problem. I'm going to say string.from, and I can say leave that value the way it is. And now if I run this again, it should still be fine, and it should now provide me the name that I provided. So I'm probably just going to come back in here and change this again to struct. Again, notice that we can now use this on any product, on any struct basically. So I can again come down here, and now this should be new products, and this should also just be products. Like this. Again, this should still work. So the interesting thing now is that I can actually now come down here and say general, and I create a new struct, and I can call this Anthony, something like this. And now I now have the option to actually copy all of this and come down here and add all those implementations basically. So I can come do something like this. And of course, I need to add some fields. I can also copy this one. See, I don't want to type out everything. So I can copy here and say first name and last name. And now I should be able to, of course, add the implementations basically on my struct. So now the only thing, of course, is that this struct over here expects us to have optional attributes and not, but we can actually take it out. It's not a problem. And we should have these other ones. So now we can also maybe also, I don't even know what I'm going to get in the end, but let's see what I get anyways. So I can say let's Tony is equal to, maybe I can now say, what did I call it actually? Anthony. So I can now say Anthony dots, now I can say new Anthony. I provide the first name, and the last name. And I can really play around with this. So, but I'm going to leave you to, of course, take your time and explore this at your own leisure. Yes, I'm going to clean this up a little bit. Why is it in two lines again? I'm going to put it again in two lines. But anyway, guys, that's really what I wanted to show you in this series. It might have been a really long one, but the point is that I'm glad that in the end that you would be able to, of course, grasp everything I tried to show you in this series. So we've been able to, hopefully, with covering all these different implementations or these different procedural macros in Rust, I hope you should be able to, of course, go ahead and have your own implementations for whatever it might be that you will be working on, say for fun or at work. And again, like you, as usual, if you run into questions, if anything is not clear, or if you would like to, of course, make suggestions, I'm always open for them. So please feel free to reach out to me, leave your comments, and I will definitely get back to you as quickly as possible. And that will be all, guys. And of course, if you're new, you know what you have to do. Go ahead, subscribe, and turn on the notification bell, and you would be notified each time we have a new content, because we promise to always bring you interesting topics, and we also try to explain them as and make it much as understandable as possible. So that will be all, guys. And until we see each other next time, have a lovely evening and bye bye.